In this lesson, we're going to do some examples of two new exponent laws that we've been working with, which is the zero exponent law and a negative exponent law. Before we go through what each exponent law is, let's see if we can just figure it out on our own. So let's take a look at this first example. 5 to the power of 4 divided by 5 to the power of 4. So one way we could do this is by subtracting those exponents, because we know the quotient rule. If we have the same base and we have an exponent and an exponent, we can just subtract those exponents. So this should be 5 to the power of 4 minus 4. And what is 4 minus 4? It is 0. So this is just 5 to the power of 0. Well, what is 5 to the power of 0? Well, let's try to do this a different way. What if we found what 5 to the power of 4 actually is? If we put in our calculator 5 times 5 times 5 times 5, so 5 4 times, then we get 625. So let's do it a different way. This top part is equal to 625. How about the bottom? The bottom is also 5 times 5 times 5 times 5, so 5 4 times. And if you multiply that in your calculator, you get 625. So what is 625 divided by 625? If you're not sure, check your calculator, but all we're asking is how many times does 625 go into 625? And the answer is 1. Anytime you divide one number by itself, you always get 1. So if we take 5 to the power of 4 divided by 5 to the power of 4, we always get 1. So we got two different answers for the same problem. We use exponent laws and we realize this is 5 to the power of 0. And we just use our logic and we realize that this has to equal 1. So what that means is 5 to the power of 0 is equal to 1. Actually, anything to the power of 0 is equal to 1. So we said 5 to the power of 0 was our final answer, which is just 1. So anything to the power of 0 is going to be 1. So if we take a look at our exponent laws here, here is our new exponent law. Anything to the power of 0 is always equal to 1. So let's take a look at B. If anything to the power of 0 is equal to 1, what would this be? Let's take a look at B. So anything to the power of 0 is equal to 1. So now we have A times B all to the power of 0. What is this equal to? Well, anything to the power of 0 is equal to 1, so the answer has to be 1. Maybe you're like, maybe you want to do it this way. Maybe you want to put the 0 to the A and the 0 to the B. That's fine too. Maybe you could do A to the power of 0 and B to the power of 0, but A to the power of 0 was just 1. And B to the power of 0 is just 1. It just all equals 1. So anything to the power of 0 is equal to 1. Let's try another exponent law now, our last one, which is negative exponents. So let's try C. If we were to use our exponent laws to solve this, what would we do? Well, just like that first example, we would subtract these two numbers. So we would have b to the power of 4 minus 7. And what is that? Well, that's just b to the power of negative 3. So we've never seen negative exponents before. So let's try to solve this in a different way. If I were to rewrite this long ways, I could just write this out as 4 b's on the top. So b times b times b times b all over 7 b's at the bottom. So b times b times b times b times b times b times b. That should be 7. So we've got 1, 2, 3, 4 on the top and 1, 2, 3, 4, 5, 6, 7 at the bottom. So let's cancel out the b's that we can get rid of. So these two b's will cancel out to make 1. These two b's will cancel out, these two b's and these two b's. And how many am I left over with? I'm left with 3 b's. But where are they? They're at the bottom of the fraction. So at the bottom of the fraction we have b 3 times. And up at the top of the fraction, what do we have? Well, b divided by b was just 1. b divided by b is just 1. We talked about that. If you divide something by itself, you just get 1. So there's a 1 on top here. So we're used to our final letters being at the top of the fraction, but sometimes you can have leftover letters at the bottom of a fraction. So again, we solve this question two ways. in our long way, we realize that it's going to equal to 1 over 3b's. And using our exponent rules, we realize that we would just get b to the power of -3. So we got two solutions. Just like last time, that means that these two must be equal. So that means that b to the power of -3 is the same thing as 1 over b to the power of 3. So what's a shortcut? How can we get from here to here? Well, they have something in common, which is actually they're the same fraction. What I mean by that is this is the fraction 1 over b. This one doesn't look like it's a fraction, but can we make this guy into a fraction? We can just divide this guy by 1. So we have over 1. So now let's take a look at what's a short to get from here to here. Well, over here we've just flipped this fraction. All we've done is just flipped this fraction, and then we've made this exponent positive. So let's try it with this guy here. Let's change this from exponent 3. Let's change it to a different exponent so you don't think it only happens with 3. Let's make this to the power of -5. Okay, so I just changed this to the 4 to the power of -5. So we're dealing with another number. I can rewrite this as a fraction first and flip it and then change that exponent to positive. That's what this means. So let's write this as a fraction first. Well, it doesn't have a bottom of a fraction, so I'm just going to put it over 1. Okay. And now because my exponent is negative, I can't leave it negative. So I'm going to do my trick. I'm going to flip the fraction first and then make the exponent positive. So I'm going to flip this so it's 1 on top, 4 at the bottom, and that 5 is attached to the 4. So I'm going to make it positive. And we're done. Now what we can do is check to make sure it's right. We can check this in our calculator. So try 4 to the power of -5 in your calculator, press equals. And then try this guy. Try 1 divided by 4 to the power of 5, press equals, and those two things should be the same. So every time we see a negative exponent, and it's all we have to do is make this into a fraction if it's not already, flip it, and change the exponent to positive. So make it into a fraction, flip it, and change the exponent into positive. Now let's try some harder examples. So let's try these example 2 now. So we're going to start with A. All right, so we have 6 to the power of -4 times 6 squared. So normally we could write this out long ways, like this is 6 2 times. This is not 6 4 times, it's 6 -4 times. So we can't really write this out all expanded, but we can just use the exponent laws that we already know. We know that when we multiply, we just add those exponents. So just because there's a negative number doesn't mean we're going to do anything different. So we got to use those exponent laws and just add them together. So I'm going to do 6 to the power of -4 plus 2. And if you are still having trouble with integers, put that into your calculator. That's going to be 6 to the power of -2. So right now, if this was out of 3, we have 2 out of 3. We are almost done. But we cannot leave a negative exponent. So we are going to do exactly what we did up here. So if you remember this example here, if we have a negative exponent, we got to make it into a fraction, if it's not already one, flip it, and make that exponent positive. So let's go ahead and use that for this example right here. So we have a negative exponent. Step number 1, make it into a fraction. It's not a fraction, so let's make it into 1. So I'm going to put it over 1. Step number 2, flip it. We're going to flip this guy so that the 1 is on top, and then we have the 6, and then make that exponent positive. Where does the exponent belong? Beside the 6. This -2 belongs to the 6, so now there's going to be a 2 beside the 6, and that is our final answer. Done. Now let's try another one. Let's try B. We're going to get harder and harder and harder as we go. So let's try this guy. Can we use our exponent laws to figure out this one? Well, we know that this is, there's division here. We remember this is 6 times at the top. This is not 4 -2 times, so we can't really write it out, but we know what to do. We just have to subtract these two. So let's go ahead and do it. Just because there's a negative number doesn't mean we're going to do anything different. So we're going to do 4 to the power of 6 minus 2. Now, is this right? This is what 99% of students are going to try. But have I subtracted it? No, I've actually just added it. Just doing 6 minus 2 is just like saying 6 plus negative 2. That's just going to be 6 minus 2. If I have to subtract them, there's got to be 2 negative signs. I got to do 6 minus negative 2. So there's supposed to be 2 minuses in there. So let's erase this guy and do this again. This is supposed to be 6 minus negative 2. And if you remember your integer rules, either throw that into the calculator, but if you have 2 minuses beside each other, they just turn into a plus. So when we subtract 6 minus negative 2, it's actually just 4 to the power of 8. And if you're not sure, again, plug that into your calculator. 6 minus negative 2 is equal to 8. So we have 4 to the power of 8. So do we need to change this? No, we don't have any negative exponents, so we are done. It's not like the last example where we were left with a negative. This one's a positive, so we're done. So let's try an even harder example now. Let's do C. Okay, so now we're using all of our exponent laws all together. So we have 4 times x to the power of negative 2 times y to the power of 2 times 2 times x to the power of negative 3 times y to the power of 4. So we remember in the last cycle, we can just collect the terms that we can multiply together. Like we can multiply the 4 and the 2. So I'm going to rearrange it so that the 4 and the 2 are beside each other. So I'm going to do the 4 and I'm going to do the 2. And I'm just going to check it off. Okay, move the 4, move the 2. How about the x's? Let's move the x's beside each other. So I have x to the power of negative 2, and then I have x to the power of negative 3. Check and check. And how about those y's? I've got y to the power of 2 times y to the power of 4. Check it off, check it off. So now I don't even need this first row. I just need to look here. Let's do step by step. I can multiply 4 times 2. I know that's just going to be 8. And then I can multiply these two. What's the rule? I don't know how to write out negative exponents. So we actually got to use our shortcut. What do we do with these two? We add them. So this is going to be x to the power of, what the heck is negative 2 plus negative 3? Negative 2 plus negative 3 is just going to be negative 5. And then these guys, again, same rule. We're just going to add these two. So we have y to the power of 2 plus 4. That's just 6. So this is a great answer. And if we left it this way, we have 3 marks out of 4. But to get that last 4th mark, there's something wrong with this, and it's right here. We can't leave any negative exponents. So we've dealt with individual negatives, but something like this one, for example, we were just left with 1 negative, that's it. But we haven't seen what it's going to look like if I've got a negative plus a whole bunch of other terms around it. So let's take a look at this guy. The only one I need to change is this one right here. So I'm going to show you one way to do it, and then I'm going to show you a shortcut. So when we have more than one term going on, just remember the only thing that needs to change is this guy right over here. So this guy right over here. So we're still going to use our same rule. We're going to make it into a fraction first. So I'm going to put it over 1. And we're going to flip it and make the exponent positive. So I'm going to show you the long way first. I'm going to show you the shortcut. Okay, so the 8 is doing nothing wrong, so I'm going to leave the 8. I'm going to flip this fraction right over here. So I'm going to flip this guy, so it's going to be 1 over x to the power of 5, and then we have y to the power of 6. So this can all just be written as one big numerator, 8 times 1 times y over 6. And if you're lost, don't worry, I'm going to show you a shortcut. 8 times 1 is just 8, y 6 over x 5. Okay, so if that's just confused the heck out of you, I'm going to show you a shortcut that we can use. So let's just erase our guy over here. Okay, so let's erase this guy right over here. Okay, so let's say that we finish off with this answer right here. Let's also erase this over 1 for a second. Okay, so here is our final answer, and let me show you a different way to do it. So another way to deal with negatives is thinking about upstairs and basements. So we have the top of a fraction, we have a bottom of a fraction. So anything that's not breaking a rule is going to stay on the level that it is. So this 8 isn't breaking any rules, so it's going to stay up top, and this y to the power of 6 isn't breaking any rules, so it's going to stay up top. Any exponent that's breaking a rule, so that's negative, is going to change floors. So this guy is going to go from the top floor to the bottom floor, and everything else is going to stay the same. So I'm going to show you what I mean. We're going to start off with a fraction. So we've decided so that we have a division between the upstairs and the downstairs. We're going to work on the terms one by one and decide if they're allowed to stay upstairs or we got to send them down. So let's start with the 8. Is the 8 doing anything wrong? Does it have a negative exponent? Nope, it's doing absolutely nothing wrong, so we're going to leave it upstairs. How about this guy? This one guy doing anything wrong? Yes, it has a negative exponent, so this one gets sent downstairs, and it's going to be put to the power of positive 5. How about this y to the power of 6? Is it doing anything wrong? Nope. So we're going to leave it upstairs. It's going to be y to the power of 6. So we got the exact same answer without doing any of that flipping business. So if we're just left with one term, it's so easy to flip. But when we've got multiple terms, it can get really confusing with the fractions. And let's just use the upstairs downstairs trick. So let's try it one more time. So here is our final answer. Let's do one more example together. Okay, so here we go. Let's take a look at this example. So we have this whole thing raised to the exponent of negative 1. So we know that if that was a 2, we would just take every single thing inside and make it to the power of 2. So now it's all to the power of negative 1. So we're going to take every single thing inside and make it to the power of negative 1. Here we go. So we're going to do the 3, and we're going to do that one to the power of negative 1. Then we're going to do the a to the power of negative 2. A to the power of negative 2 is all going to be the power of negative 1. And then the last one, we're going to do b to the power of 4, all to the power of negative 1. And then we're going to decide what to do next. So do we know what 3 to the power of negative 1 is? Maybe you're saying, Miss, we can flip it. We absolutely can, but let's save all the flipping to the end. So right now there's nothing we can do. How about this, guys? Is there any exponent rules to help us with this? Well, we have a power to a power. What do we do with those two? We multiply them. So we have first 3 to the power of negative 1, and then I'm going to have a to the power of negative 2 times negative 1. That's going to be positive 2. And how about the next one? We also have another power to a power. We can multiply those. So it's going to be b to the power of negative 4. So there's nothing else for us to simplify. So this is another, we got a 3 out of 4. Let's get our fourth mark because there's something that's not allowed here, which is negative exponents. So we're going to use the same trick that we used right over here, our little simplification trick, which is that if we have multiple terms, just like we do here, we're just going to use the upstairs downstairs trick. So if there's nothing wrong with it, we're going to leave it upstairs, and if there's something, if there has a negative exponent, we're going to send it downstairs so that it's positive. So let's do the same thing right here. So one by one, first of all, let's start with a big fraction bar. So let's start with our fraction bar. Okay, one by one. This guy, is it doing anything wrong? It absolutely is. It has a negative exponent. So we're going to bring that 3 down to the basement, and we're going to put it to the power of positive 1. Let's keep going. How about the a squared? Is it doing anything wrong? Nope, it's just a to the power of positive 2, so we're going to leave it upstairs. Okay, how about this next guy, b to the power of negative 4? Is it doing something wrong? Yep, it has a negative exponent, so we got to send it downstairs. b to the power of positive 4, and we're done. We know how to rewrite 3 to the power of 1. 3 to the power of 1 is just 3 one time, so we can just rewrite this as a squared on the top, all over 3b to the power of 4, and we are done. So let's go over really quickly what we've reviewed. So we added 2 new exponent laws. So one of our exponent laws is the 0 exponent rule, which is that anything to the power of 0 is just going to be 1. So we did this guy is just going to be 1. This whole thing also is just going to be 1. And then we dealt with negative exponents. So we know that if we have a negative exponent, let's just move this guy over here, and we're just left with one little term, we know we can just flip that fraction and make that exponent positive. So if there isn't a fraction, just put it over 1, just like we did here. And when we have negative exponents, we got multiple terms. So like this guy right here, where we had an 8, an x, and a y, and it's confusing to flip the fraction, then we can just keep everything upstairs if it's not doing anything wrong, and bring any of the negative exponents down to the bottom of the fraction. Same with here. Anything that has a positive exponent, we're going to leave exactly where it is. Anything with a negative exponent, we're going to send it down. So now try the rest of the examples on your own.